Okay, so lesson 8.3 is going to address conditional probability. So conditional probability, we'll talk about what that is. So the key concept here is that two or more events are dependent if the occurrence of one event affects the probability of the consecutive events. This changes the set of possible outcomes for consecutive selection. When two or more events are dependent, a conditional probability exists, and it is the probability that some event will occur given the other has already occurred. So this is the formula for conditional probability. I am going to be referencing that throughout the lesson. So just so you know, that's where I got it from. It's right from this front part of the notes. So how you say this is the probability of B given A, meaning given that A has occurred, is equal to the probability of A and B, so the intersection of those probabilities, divided by the probability of A, which is the second item. Okay? Yes? Oh, what it means? Yeah. Sure. So B given A, that's the slash, is equal to, it's the probability of A and B over the probability of A. Okay. So data from the two different categories can be organized with a contingency table or a two-way frequency table that is organized to make it easier to find probabilities. Okay? So the innermost data is called the joint relative frequency, and the outer data is called the marginal frequency. So the way I always tell students to remember this is joint are the ones in the middle, and you know how we call it the margins of the paper? It's the edge of the paper. That's going to be the edge of the boxes, are the margins, okay? The marginal margin. So basically, for a frequency table, you're going to add up the totals, and those totals are going to represent different things. So before we get into using any frequency tables, let's just refresh our memory on how we deal with these situations. So it says here we have 2 blue and 3 red marbles are in a bag. What are the chances of drawing a blue marble and then a red marble? So what's the chance of drawing a blue marble here? Good, 2 out of 5. Now something that we haven't really talked about, we've always mentioned if it's a replacement or not. If they don't say replacement happens, you assume that it doesn't happen, right? Because most of the time you're not going to be replacing it unless they tell you to. So that's going to be times, because then you're choosing a red marble. You want both things to happen at once, so it's multiplication. And now how many marbles are left in the bag? 4, because we took away 1. And how many red marbles are in the bag? 3. So your probability here is 6 out of 20, which is equal to 3/10. 30%. Exactly. So in this lesson, I am going to be, there's certain like just basic calculations. I'll just be giving you the final answer so we don't worry too much about the reducing and all that. You all know how to do that. So just a heads up. What are the chances of drawing 2 blue marbles? So what's the chance of drawing the first marble as blue? Same rules as before. How many blue marbles do we have? Out of the total, which is? Good. And then times, because we want to draw 2 blue. How many blue marbles are left in the bag? 1. And how many total marbles are in the bag? 4. Good. So this is 2 out of 20, which is 1/10. So 10% chance of that happening. So does anybody have any questions about that so far?
Where'd you get the 1/4?
So you had 5 marbles in the bag,
Okay.
and you took one of them to be a blue marble, right? That was 2 out of, you're good. That was 2 out of, around the -3. That was 2 out of 5, right, the chance?
Yeah.
Now, if you took a blue marble out, how many blue marbles are left?
1.
Good, and there's only 4 marbles left in the bag if we took one out, right?
Mm-hmm.
So there's only 1/4 chance now.
But if you're already drawing 2 blue marbles out?
No. This doesn't mean you've drawn 2 blue. That's the chance that you'll draw a blue.
Oh, okay.
Yeah, don't think of it as what you actually do, but what the chances of that happening are.
Okay.
And then it will make more sense. Yeah, so this isn't literal, it's probability. Does anyone else have any other questions about this part? Okay. So now we're going to do conditional probability table, okay? So we're going to be looking at this scenario and we're going to be finding the totals, okay? So these outside parts are the totals. Now, sometimes they're going to give you like at boxes to put the totals, and sometimes they won't. Sometimes you just have to find them on your own and put them on the outside of the box. So we are going to add up the total here by just simply adding downward, okay? So that's, I actually did the math earlier so that we could save some time. So the total here is going to be 7,539 if you add up all three of those amounts, okay? And if we add up these amounts right here, that's going to be 9,933. And then we're going to add this way. So this is going to be 4,328. We're going to add the two totals here, which is going to be 9,841. Add across 3,303. So now, this is where you want to think about the fact that we want to find the total number, like the ultimate total. You can either find that by adding these two or these two. And when you do that, those amounts are going to come out to be exactly the same, theoretically. So, my suggestion is to always add both to make sure that you get the same number right here, okay? It should be the same number, whichever way you decide to add. So it's a good way to check your work to make sure you didn't make any calculation errors, okay? So, this is what we have so far. These are our subtotals and our totals. And now we're going to calculate some probabilities. So, these are students that went to two-year college, four-year college, and graduate school separated by gender. So we're going to find the probability. So, we're going to just look at a general probability here. How many total females are there total? What do you think? Good, 9,933. And how many total students are there in general? Good, 17,472. So that's just the probability specifically of all the female students, right? So 56.9%. So now we're going to move on to female students given they graduated school. So this word right here, this slash means given, okay? So I want to talk about the easiest way to do these types of problems with the slash. So the first thing you're always going to do when you see the slash is what's the chance, or what's the amount of students who are female and went to graduate school? How many of those are there? Yeah, 1,954 students are female and went to graduate school, right? And then, to find the denominator, you take the total of the second part of the slash. How many of total students went to graduate school? Good, 3,303. And that amount comes out to be approximately 59.2%. Okay? So, now we're going to move on to our next part. My blinds are all broken over there. So basically what this means is given. So you're assuming we're looking at the total pool of graduate school students. So now we're going to look at students who went to a two-year college, given that we're only looking at male students, right? So let's go ahead and set this up. So the first thing you do is find the number of two-year college students who are male, which is how many? Correct. So 1,866 over over the total number of male students, which is 7,539. So this amount is always your denominator, okay? Does everyone see that? So that when you do the calculation, is going to be 24.8%. And the last one we're going to look at is going to be male students, given we're only looking at the students who went to two-year college. So how many male students went to two-year college? Good, 1,866. And now, what's different about this one? Good. We're using a different denominator. We're using the number of students who went to two-year college. And that amount comes out to be approximately 43.1%. So that is how you do the two-way frequency table. Does anyone have any questions so far? All right. So now we're going to try another example.
What was that last one we just asked for?
43.1%.
Thank you.
So now we're going to be looking at recycled and non-recycled waste by material type. So we're going to find our totals, and like I said, sometimes they'll give you the boxes for the totals, sometimes they won't, sometimes you have to write them in yourself. So we're going to find the total, right here, the total amount of paper. So this is waste collected. So we add up the recycled paper and the non-recycled paper, and that gives me 83. We add up the recycled and the non-recycled metal, which gives me 20.8. The recycled and non-recycled glass is 13.6. Plastic is 30.7. And then other, so like materials that don't fall in that category, is 68. And then from there, we're just going to add up all the recycled material, the amount of material that's actually recycled. And then the amount of material that is not recycled. And then this total is by either adding all the recycled and non-recycled, or adding all the total material. And that amount should give you either way, whichever way you decide to add, 216.1. So I just did the math to save the time, but I know you're all capable of doing that. So now we're going to go ahead and start calculating some probabilities. So what is the probability that the material is paper given it is recycled? So here's a little bit of a tip for you. Whatever they say given is recycled, that is your denominator. Okay, so if they don't have it set up in the probability way, that's going to be your denominator. So what's the total number of recycled material? Good, 79.4. And then to find your numerator, you take paper that is recycled, which is how much? Good, 45.2, which will ultimately give me 56.9%. So the next one that we're going to do is, this one doesn't always give you the given, sometimes you have to find it. So it says, what is the probability that a sample of paper is recycled? Okay, so this can be a little tricky to figure out what the given is. So what is the probability that a sample of paper is recycled? What do you think the given is, paper or recycled? Good, paper. Yeah, we will eventually. So how this works is, probability that a sample of paper. So we're specifically looking at the paper. And then within that, our numerator is going to be a type of paper, right? So given that a sample of paper, so we're assuming that it's a sample of paper, and we want to know how much of that paper is recycled. So your given is your denominator, okay? So how much paper is there total? Good, so we have 83 tons of paper. And how much of that paper is recycled?
45.2.
Good. So the trickiest part is figuring out what your denominator is. You just have to kind of read the question and interpret the understanding. So we're looking at samples of papers that are recycled, and that amount is approximately 54.5%. So this is just a little bit of a tip. Sometimes the given may be hidden, and there's only two options for the given in the problem. It's always one of the two items. So just kind of read through and see which one is going to be your denominator based on the wording of the question. So the next one we're going to be looking at is utility company asks 50 students, what am I doing today? Customers whether they pay their bills online or by mail. So we're going to find the totals. So there are 20, 30, good, 36, and 14. And either way you add, you should get 50. So they asked 50 total people, okay? So now we're going to do our probability. What is the probability that a customer pays a bill online given that the customer is male? So our given is our denominator, and how many total males are there? Good. Okay. And then how many of those males pay their bills online? 12. Yes. So that comes out to be 60%. So the next one says, what is the probability that the bills paid online are paid by females? So, what's the given here? Anybody know? Is it online or females? Online. So we're talking about the bills paid online and then the percentage of those online bills paid by females. So, this is going to be your denominator. So how many people in general pay their bills online? Good. And how many of them are female? Good. So this amount is going to be 66.7%. How is everybody feeling about this so far? Actually not that bad. I'm glad to hear it.
This is, if I can be honest, like the first lesson that I've completely understood.
Yeah, like I get it.
Appreciate the honesty.
Because all you're doing is like adding and just dividing the fractions, so it's not.
The only tricky part is knowing what the given is, I guess.
Yeah.
So does anybody have any questions about this slide? Alright. So the next one we're going to be looking at is going to be conditional probabilities using a tree diagram. So this is a little bit different representation of data. But I think I can make this a little bigger because I feel like it's kind of hard to read. So hang on a sec. I know there's a way. There we go. Okay, that's a little better. So, it says a high school system surveyed adults who attended high school 10 years ago, and the survey reflected the following. So, 85% of the adults surveyed graduated from high school, 90% of the graduates were happy with their present job, and 60% of the non-graduates were happy with their present job. So our goal is to find the probability that the person who graduated from high school is happy with their present job, and we're going to be using a tree diagram. So, you're a student, okay, and there's two things that can happen to you as a student. You can either graduate high school, or what? Don't graduate high school, right? So, let's say you take the path that you graduated high school. What percent of these people at this high school graduate?
80%.
Good. So you're going to write 85, but you're going to write it as a decimal, so 0.85. So you have an 85% chance of graduating. And they don't have to give you the opposite or the complement. You can find that yourself. So the other option is that you don't graduate. So you're a non-graduate. Good. And the chance of not graduating is 0.15. It's the complement of the chance of graduating, right? Everybody see how I got 15 there?
Yeah.
Okay. So then, within the people who graduate, we dealt with this one. 90% of those people were happy with their job. So, from graduates, we have people who are happy with their job, and that's 0.9. They're overestimating, I think.
A little bit.
The school just has happy people. So the other option is, what's the opposite of being happy with your job?
Sad.
Sad. And how many people are sad with their job? 0.1, 10%.
There is no way that is a true
They
statistic.
should switch the numbers around just so you know.
I'm happy with my job. All right, here's one
Okay,
statistic.
but I feel like people say that.
There's the one
I feel like people lie when they say they're happy.
I'm not lying.
You might not be lying. But somebody who's like
Lying about lying about lying about lying? No.
This could go on forever.
It could. It could.
I
Okay.
feel like truly being happy with your job is waking up and not going, okay, I have to do this.
I think that you have to keep into account that like there's things in life that you like and enjoy, but it doesn't mean like every day you're gonna always like be in that same like you're not gonna always have a good day every day, even if you love what you do. So, you know,
True.
just saying. Anyways, so there's good days and bad days whether or not you like your job.
I feel like the number should be a lot less than 90% of the people love their job.
Now my pen's not. There we go. Okay, my pen's back. So, 90% are happy with their present job. We dealt with that. Now, 60% of the non-graduates were happy with their job. So,
That sounds realistic.
yeah, realistic, right? So, 60% were happy. So, happy is 0.6.
That sounds more realistic than 90%.
And then sad is 0.4. So now we're going to track through the tree diagram to figure out what the situation is. So what is the probability that a person who graduated from high school is happy with their present job? So what decimal graduated from high school?
It's
85.
Good. Times how many of those people were happy? 0.9. So if you multiply those two together, that will give you the amount of people who graduated and were also happy. So 0.85 times 0.9, and that should give you approximately 76.5%. So any questions about that so far? All right. So now we're going to use conditional probability to figure out the following using some data. Okay. Now, whenever you're doing calculations with percents, you need to convert those percents to a decimal, which I think you're all pretty familiar with. So, of 2 math tests, 25% of the class passed both tests, and 41% passed the first test. What percent of those who passed the first test also passed the second test? So, basically, we're looking at a fraction here, and the total number of students that we're looking at are specifically students who have already passed the first test, right? So how many, what decimal of students have already passed the first test? Good, 0.42. So we're looking at of the students who have already passed the first test. So we don't care about those who didn't pass. We're only looking at the ones who have, which is why that's our denominator. Now within that denominator, of course, thank you. So within that denominator, we have a certain amount of students who passed both tests, right? So what percentage or what decimal of those students passed both? 0.25. So the ones who passed both, the ones who only passed the first, that will help us and tell us what percent of the students who passed the first test also passed the second, and it's about 60%, 59.5%. That's it. That's literally it.
See, why can't we have been doing this?
Like all year.
Because this is not probability and statistics class.
Well, this should be.
So a jar contains black and white marbles. 2 marbles are chosen without replacement. The probability of selecting a black marble and then a white marble is 0.34, And the probability of selecting a black marble on the first draw is 0.47. What is the probability of selecting a white marble after drawing a black? So we're assuming that we've already drawn a black marble as our first draw. Okay? We're just looking at the people. So you have people who didn't draw the marble, they're already out. We don't care about them. We're only worrying about the ones who picked the black marble first, which is what decimal of people. Good. So 0.47, it's the probability of people who chose the black marble first. And within that probability, we want to look at how many of those people picked the white marble second, which is how many?
0.24.
Good. So that amount is going to come out to be 72.3%. Now the next one is the probability a student is absent on Friday is 0.03. Since there are 5 days a week, the probability that it is Friday is 0.2. You know what I mean by 5 days a week, 5 school days. What is the probability that a student is absent given that it's Friday? So we only care about absences on Fridays right now. So what's the probability that it's Friday? 0.2. And then we're looking at specifically within that amount, how many students were absent that day, which was what? Good. 0.03. And that amount comes out to be?
0.15.
Yeah, I think so. Yeah, 15. About 15%. That's it.